Now I'm going to talk a little bit about storage tanks. So storage tanks are also important in terms of process. They are also kind of considered as ancillary equipment. They have different types, and we have different They have also different kind of design, and we have to consider them, their design, different type of storage for. So about the tanks, the storage tanks, they have many applications in industries in general, and as well as in chemical industries, especially in oil and gas industries, that we usually extract the gas and the natural gas and oil, and we need to store it somewhere and then distribute it or send it to the downstream processes. So they can have various shape. Okay, these tanks, they can have various shape, various size, and also they are named based on their function, particular function. So we can have kind of different type of tanks. As I said, they are named based on their function. We can have head tanks, charge tank, sump tanks, and holding tanks. So no need to go through the details of each of them. I'm just going to talk mainly about the storage tanks. And the most important function of these tanks is storage, just providing a storage capacity. So I can say there is a big difference between these different type of tanks. The most important function of each of them is storing the liquid, mainly the liquid or the slurry, which is the mixture of both liquid and solid. So, like, the substance in the tank can be water. Come on. So the substance in the tank can be water, can be some feedstock, some liquids, some finished products. Let's say we produce some chemicals and we need to ship it. So before shipping it, we will store it in the tank. And unfinished product, let's say when we extract the petroleum, before we send it to the refinery or petrochemical plant, we store it, or sometimes we need to blend that liquid with some other liquid. So those are the situation that we use this kind of storage tank. So when you store some liquid, depending that the nature of that liquid, so it can have if let's say if you are storing some petrochemical products, it can have some contaminants, it can have water, some emulsion, let's say oil in water, or some dirt, some solid particles. So when you store the liquid and when you give it enough time, so this undesirable substance, they can be removed from your liquid, or there are some methods that we can use to remove them, especially for dirt or solid particles that are usually heavier. They can settle at the bottom of the storage tank, and then you can drain them out by using some devices. Okay, and also you can use the storage tank to mix some other products together. So storage tanks are not only used to store the tank, they can be used as a mixer or blender as well. So classification of tanks. So tanks are divided to three main parts based on the operating pressure or internal pressure of the tank. We have atmospheric tanks that are working at atmospheric pressure or near atmospheric pressure. It can be a little bit above the atmospheric pressure, and in most of the case they can be open tanks since they are working at atmospheric condition. So imagine if this is my tank, since it's atmospheric condition, we don't need to even close the top of the tank. We don't even need this kind of lid, so it can be open to the air, but it depends to the type of liquid. If it's water, yes, it's okay, but if it's some volatile hydrocarbons that they can vaporize and they can go to the atmosphere, they can go to the gas phase, so in that case we have to close it. So they are called atmospheric tanks because they work at condition close to the atmospheric pressure, and the pressure is slightly above atmospheric pressure, above 3.5 psi. So atmospheric pressure is 14.7 psi, 14.7 psi. So this tank, they work a little bit above this atmospheric pressure, which is good. So then we have low pressure tanks. So this type of tanks, they usually work at so this text needs some kind of revision. Okay, so don't pay attention to all the parts that is written, all the sentence written here in this paragraph. Low pressure tanks are usually tanks that they work at lower pressure, okay, than atmospheric. So sometimes we need kind of creating vacuum in those kind of tanks to make it works below atmospheric. Or there are tanks that they don't really work at very high pressure. Maybe the pressure can be little bit above the atmospheric, but is not very high pressure, let's say 10 atmosphere or 20 atmosphere. So it's like it still can be considered as low pressure, that it works at relatively low pressure. Relatively low pressure means a little bit above the atmospheric pressure. Okay. So there's two type of tanks, atmospheric and low pressure tank. They are usually used in case we have liquid that doesn't vaporize at ambient temperature, like water. Water evaporizes at ambient temperature, but it's not like alcohol. So it means it's used for liquid that has high boiling, high boiling point, and they don't vaporize or they don't go to the gas phase at low temperature, ambient temperature. And in that case, they can be even open top. It means at the top of the tank we don't need any roof, anything, or they can be fixed roof, or they can be even floating roof. I'm gonna talk about these three types later. So the atmospheric and low pressure tank that are working at relatively atmospheric or low temperature, little bit above the atmospheric temperature pressure. So they are used for liquid that they don't vaporize easily at ambient temperature. And they can be three types. They can be open roof, fixed roof. Fixed roof can be either cone or dome, that I'm gonna show you some figures later, or it can be floating. So three different types. So those are these the types are the most commonly used type of tanks. So now, okay. Vertical tanks, as I said, tanks they can be vertical or horizontal. So for vertical tanks, we have we can have open top or fixed top or floating top. So open top, so is like the tank that you see here. The top of the tank is open to the air. It doesn't have any cover. It doesn't have any kind of lid at the top. It's just open to the air. So this kind of tank are usually used for storing city water, fire water that is used for firefighter stations, and cooling water. Okay, that's the main. We cannot really store chemicals, especially dangerous chemicals, in the open tank. So those are some of the application of this tank. So based on the type of the roof, it can be fixed. Okay, as I said, the fixed roof can be, you know, like is a tank that the roof is totally fixed, completely fixed, so it doesn't move. It can be dome shape or conical shape, something like this. So it can be like dome or it can be conical shape, so depending to the application. So these tanks, they can work in atmospheric condition, low pressure and high pressure. Atmospheric condition means the internal pressure in the tank is atmospheric. The low pressure means low pressure means low pressure means that it can even work at pressure lower than atmospheric, below the atmospheric pressure or vacuum, or it can work at very high pressure. So in all this case, we can use the fixed roof tanks. So they have application in all these cases. Now, okay, so some additional information about the fixed roof tank. So they are usually a cylindrical shape, a steel cylindrical shape, that the roof is permanently attached to the top of the tank. And as I said, it can be cone or dome shape. It can be any of this shape. Then so the fixed roof tanks, they can be both above the ground or underground. So it can be both of them. We can use them in both conditions, underground, above ground, and are usually constructed with steel and some fiberglass overlay at the top, or fiberglass reinforced polyester, so to protect the roof from water, rain, intrusion, and so on. So so most of the tanks that we have in industries are vertical. Horizontal tanks are also used, but they usually have capacity less than 40,000 gallons. This is maybe one of the reasons, and they usually need more spaces. That's maybe one of the reasons that is less common in industries. So the fixed roof tanks, they are used, they are widely used in refinery storage, refinery product storage, that we have all different type of liquid and hydrocarbons. However, like floating roof tanks in the recent years, they have attracted more application, and the reason is that we can handle a wide range of crude oil and volatile products. So the floating roof, that I'm going to talk about them a little bit later, in the next slides. So they are used to store volatile products, that they can create vapor. They can increase the pressure of the tank. In that case, we need to purge that pressure. So this floating roof can give us this option. So floating roof tank is a tank that, you know, you have one of the photo here. So the floating roof, we have the roof floated on the surface of the liquid. It's floated and it can go up and down. Let me clean this because it's not, yeah. So this floating roof, it can go up or down to in the tank. It is attached and well sealed to the wall of the tank. It can move, but at the same time, the hydrocarbons or the vapors, they cannot go through this openings, because it's very well sealed with some specific design. So when the hydrocarbon is vaporized, so this can move a bit up to adjust the pressure, and at the same time we can have some valves, safety valves, to purge the vapor. So this is called, you know, like the floating roof tank. They can be external floating or internal. External is something like that. It has only one roof, so this roof can float, can go up and down. So you have few YouTube links here. Like I put 4 links for you, 2 in this slide and 2 in the next slide, so you can start watching them. And I'm sure it can be helpful to understand this type of roof. Okay, so it's a roof that floats on the surface of the liquid, a stored liquid. So okay, is a welded or reverted steel plate. Okay, is a steel plate. Okay, and it can rise and fall with the liquid level. It can go up and down. So as I said, the floating roof, they have also a seal system. Okay, they are very well sealed in the wall of the tank, and that doesn't let the vapor to go out from this sealing, but at the same time it can move on the wall. So the reason that we use this kind of tank is to reduce the evaporative loss. I mean, when let's say at high temperature, when the temperature is high, so this liquid can be vaporized, the pressure can increase, so this roof can move up. Okay, so the pressure decrease, and when the temperature is low, pressure decrease, so this roof can go down toward the bottom. So in this case, it can adjust the pressure, and in that case we don't need to lose any of that vapor that we have. We can keep that vapor, so we lose less material, less chemicals. So the seal system also slides against the tank wall, and it lets the roof to go up and down. So that's another example of the top, the floating roof. So you have these 2 YouTube links, you can start watching them. So this roof here, this one, it can move up and down, and it can be used for storage of hydrocarbons that we can have some evaporation. Some of the hydrocarbon can evaporate, so we can adjust the pressure by using this kind of floating roof tanks. This is also another photo of this type of floating external floating tank. So floating roof tank. So this roof at the top is floating. It can go up and down with the level of the liquid. So it has different kind of equipment attached to it. So in those videos you can see them, but for now you don't need to go through the details. Just you need to know what's the application of these tanks and how it works. So as I said, that is the internal floating roof. So we have a fixed roof and one floating roof that is moving up and down in the tank. So this fixed roof doesn't need to be made of very professional material, because it doesn't need to withstand a high pressure, and this roof needs to be designed and installed accurately so that it can adjust the pressure. So this part you see is the sealing part, that they seal the roof with the wall of the tank so that no vapor can go out of this part. Then okay, so this is another example of internal floating roof. So we have one roof at the top which is fixed here, and we have another roof that is floating, that it can goes up and down. Now is landed, is at the bottom of the tank. So, and it usually don't reach to the bottom, to the very bottom of the tank. It means here it usually has some kind of handling bars that doesn't let it to go below a certain distance, like this one. So it's landed here. This is the minimum level that it can go, and it can go maybe up to somewhere at the top of the tank. Okay. So pressure vessels are tanks, storage tanks, but they can operate at very high pressure. So they have again a lot of applications in different industries, in different kind of application. They are used, and tanks that they operate. They can store liquid at pressure about 15 psi or 1 atmosphere. So they have relatively high volume pressure. It means they can store a high volume of liquid at high pressure. They can be a spherical or cylindrical shape, and in terms of cylindrical, they can be even horizontal or vertical. Usually the spherical shape is that the reason is it can create a big amount of volume for us, and it can create a large cross section than the pipe and tubes. Then okay, the common application of pressure vessel or pressure tank is general purpose. So this slide is important, don't forget that. General purpose: chemical processing, cosmetics processing, food and beverage, oil and fuel, which is our interest in Qatar, pulp and paper processing, pharmaceutical, plastic, polymer processing, power generation in power plant, and in energy processing. So those are some applications of such a tanks. So what we have to mainly consider when we are designing such a tank is their capacity, maximum pressure, and temperature range that they are going to operate. Capacity means how much liquid they have to store. Then so the capacity is the volume of the pressure vessel. That's the simply the definition. And also we have to calculate the maximum pressure that the tank have to withstand in worst case scenario. And also the temperature, the maximum operating temperature or storage temperature will dictate the material of construction, the material that we have to use to construct such a vessel. Then we have okay, as I said, we can have cylindrical or vertical tanks. So cylindrical tanks, they can be vertical, like this tank, this type of tank, or they can be horizontal, like this one. So each of them, they have some, advantage, disadvantage, some application, but in those cases, they have kind of a dome shape at the two end. At the two end, they have a dome shape. So this is mainly for some construction. This is some construction methods or procedure that has to be followed. So this kind of shape, they can withstand higher pressure at the bottom and at the end. So this is the reason that they are made in that way. So they are used to store different type of product at high pressure, which is above the atmospheric pressure. So mainly for volatile products that they can vaporize and they can go to the vapor phase. And so we usually, what we do in terms of like natural gas, we pressurize them. We use a high amount of pressure to make them to go to the liquid phase. We liquefy them, and then we store them in such a pressure tank, and then we ship them. So they can be okay. So like the cylindrical one, they have a main cylindrical part, which is this part from here up to here, and they have two kind of semi-sphere at the end. At the end, this end and this end, they are two. They have two spherical, semi-spherical shape. So this is the cylindrical pressure. The cylindrical pressure vessels, they are good for moderate to high pressure. So for moderately high pressure, the cylindrical one are used. So they can be vertical, like this one, or they can be horizontal. So it depends to, again, some other design aspect. There are also this type of cylindrical pressure vessels. They are also called bullets. They look like a bullet. So nothing more about this slide. Okay, this is another photo of kind of pressurized cylindrical tank, cylindrical pressure vessel or bullet. So you can see that it can be something that has a diameter as big as maybe, I don't know, 2-3 meters, and the height can be sometimes 20 meters maybe, or even more, so, or less. So it depends, to application capacity. It can be in different sizes. Then okay, another type. This is kind of our last topic in this unit. Another type of spherical pressure vessel is a spherical pressure vessel, that they can there are tanks that they are made in a spherical shape, and they can withstand a very, very high pressure. So in Qatar, I mean in general in petroleum industries, they are used for LPG, liquefied petroleum gas, that we liquefy the gas, liquefied propane, butane, that at atmospheric temperature. So we need a very high pressure to make these components to go from vapor phase to the liquid phase. So this tank, they can go to very high pressure, and the spherical shape make them suitable to be usable for very high pressure. It's like a balloon that is inflated, and it reached to its, you know, like larger shape, and it won't inflate more with more I mean blowing air or helium, whatever. So it's like a big balloon with a rigid body that doesn't deform, or the shape doesn't change. So since this in the spherical shape is very stable at very high pressure, so it cannot go under deformation at high pressure. It makes it a very stable shape without any deformation at very high pressure. Of course, the pressure shouldn't go above the maximum value allowed. So we have a design pressure for these tanks. So the design pressure of the tank is based on the amount of liquid that they are going to store, the volatility of the liquid. So the pressure never should go above the maximum allowed pressure. Otherwise it will explode or burst. So I'm gonna end up this unit 4 by this figure. So that's only another photo of spherical tanks. So we usually have few of them together to store our liquid or liquefied gas at high pressure. So this is the last of this unit. I hope you enjoyed this unit, and I hope my voice was clear. As I said, please go through this presentation, and I'm gonna have a live virtual session this week on Wednesday, so you can ask your questions, and we can discuss about any other matters. So see you soon. Take care.